Learning objectives. By the end of this lesson, you will be able to describe the benefits of traditional and agile approaches to software testing, describe the levels and approaches of software testing, demonstrate a test-driven development framework with JUnit, and demonstrate a behavior-driven development framework with Cucumber. Software testing overview. Software testing. Software testing is an investigation conducted to share information about the quality of the product and the service under test to the organization. The software testing checklist is as follows. Is the test meeting the requirements that guided its design and development? If not, there's really no value using the test. The most important thing about testing is that it ensures that the behavior of the software under development meets the requirements of the business. Next, is the test responding correctly to the inputs? If not, either there is a problem in the test or the system under test, and this needs to be figured out and remedied. Is the test functioning within an acceptable span of time, or is it running too long and making the test framework time out? Is the test working properly in its intended environments? Be careful. It's not unusual for a test to pass in one environment, yet fail in another. In order for a test to be valid, it must run reliably in a way that's appropriate to the environment in which it is operating. Is the test achieving the desired results? In order to make sure that the test is indeed meeting the desired results, the requirements which the software is intended to satisfy must be well known, both in terms of documentation and common knowledge among the development team. Tests must be created according to verifiable specification, not developers' assumptions. Otherwise, a company runs the risk of spending money developing tests that have marginal use. Traditional versus agile testing. Let's take a look at traditional testing first. It follows a predictive model with a step-by-step phased approach. It certifies the quality of the product, and traditional testing produces the final system with all the required features. Unit testing for each module is followed by integration and system testing. No feedback is provided until testing is completed, and modifications are implemented in the next release. Agile testing is different. Agile testing follows an adaptive model with an iterative approach. It certifies the quality and fast delivery of the product, even with minimal functionality. Each sprint produces a working version that has a subset of features of the final system. Continuous testing and regression tests are conducted across all iterations. And at the end of every sprint, a short, ongoing feedback cycle is produced. And finally, modifications are implemented in the next sprint of the test cycle. The important thing to understand about traditional testing versus agile testing is that in agile, continuous testing is a driving principle. Testing is conducted throughout the entire software development process, from development onto system testing, and even after the code is released. Many shops take a test-driven development approach, which is abbreviated as TDD. Under TDD, all activity emanates from predefined tests. The rule of thumb is a requirement really is a requirement once its behavior can be described as a test. For example, just saying that a requirement of the application is that it's easy to use has marginal value in the TDD world. We need to be able to test for easy to use. Designing software under TDD means that requirements will read something like, the save document feature will be easy to use. This means that a user will be able to figure out how to save a new document without prior knowledge in under 3 seconds. You see how exact that is? Taking an agile approach means that requirements are defined in a way that is quantifiable and verifiable. And tests written to these requirements can prove with little or no ambiguity that the conditions of the requirements have been met. Agile testing advantages. Let's take a look at some of the advantages of Agile testing. First, there's reduced risks. A basic practice of Agile is to develop code iteratively over many sprints. Typically, a sprint will not last longer than 4 weeks. The benefit of the iterative approach is that issues are uncovered quickly and thus resolved quickly. In other words, problems appear early and are fixed early. This reduces software development risks significantly. When a development team is following the waterfall approach, one in which problems keep accumulating until they are revealed downstream in the QA phase after development is complete, the time it takes to solve all the problems presented can become overwhelming. So too can the risks. Agile's iterative approach breaks development periods into smaller pieces and thus makes the risks more manageable. Also, an advantage is faster time to market. Agile's iterative approach not only reduces risks, it also allows features to be released more quickly from the product backlog. Users are being given features in an iterative manner. Thus, time to market is faster. Product testing as a method is a definite advantage. Product testing is a part of all and any activity in the Agile process. Testing becomes a methodical discipline that is always performed. Because QA personnel are equal members of the software development team, testing is not a special event delegated to a special group outside of the development effort. Testing becomes a method in the process overall and is conducted by many people on the development team. Easy adaptation to evolving requirements. Agile assumes that change is ever present. In fact, change is welcome. Thus, the practices that emerge within the Agile process are designed to adapt to change quickly. For example, sprints are intended to occur over a short period of time. Thus, should change need to be made, businesses don't need to wait for months to implement a change. It can be done as soon as the next sprint is scheduled to start. And the final advantage is improved quality of products. Short sprints, development processes that are designed to accommodate a change quickly, and continuous testing throughout the entire software development lifecycle have the results of increasing the quality of products overall. Implementing small feature sets means that they can be tested as the code is created, and they can be fixed quickly should the need arise. This increases code quality dramatically. Advantages of using Agile with DevOps testing. Let's continue examining the advantages of using Agile with DevOps testing. Cohesion of teams. Small teams that work closely together day in and day out create a synergy that significantly increases productivity. As team members work together closely during the intensive activity in a sprint, the strengths and weaknesses of each member become apparent. Thus, efficient workload allocation starts to take place naturally. A team member commits to performing tasks in his or her area of expertise. Also, he or she will offer to help others when problems arise. No one person can know it all. The team understands this. It's through a willingness to not only admit one's weaknesses, but also to offer help when one's expertise is needed that genuine team cohesion evolves. Easy scalability. As we've mentioned earlier, Agile processes are intended to be flexible. This flexibility makes scaling easier. Remember, under Agile, testing is a continuous activity conducted throughout all stages of the software development lifecycle. Also, automation is key to Agile. Continuous automated testing is easier to scale than a testing process that's run manually only at release time. Flexibility in process combined with automation makes scaling easy. Improve quality of products, continuous integration and testing, and process automation are Agile features that provide significant advantages in DevOps testing. As we've mentioned many times, Agile's iterative development process, along with the use of continuous automated testing, improves the quality of the software created significantly. Testing levels, approaches, and automation tools. software testing approaches. When it comes to software testing, the important thing to remember is that the role of the software development test engineer goes well beyond manual testing. In fact, in the practice of DevOps, the role of the software development test engineer is anything but that of a manual tester. In DevOps, manual testing is frowned upon except in very special circumstances, such as complex performance testing that requires a very detailed, time-sensitive approach to test preparation. The job of the software test engineer, also known as an SDET, is to design the automated tests that will be executed within a continuous integration, continuous deployment framework such as Jenkins, TeamCity, or Travis CI. Test engineers approach testing in a variety of ways depending on the situation. In terms of determining the quality of source code, the engineer will conduct a static test. A static test is a review of the code and the associated documentation in order to make sure it complies with industry standards, regulations, and best practices. During static testing, the code is not run. When it comes time to run the code, dynamic testing processes are used. This might be a unit test or a more comprehensive integration test or a system test. The important thing to understand is that the code is exercised by a test runner application, such as JUnit. The test runner executes runtime testing on the code and reports the results accordingly. There are also the exploratory and box approaches to testing, which are very closely related. Exploratory testing is a term created by Kem Kainer in 1984. According to Kainer, exploratory testing is a style of software testing that emphasizes the personal freedom and responsibility of the individual tester to continually optimize the quality of his or her work by treating test-related learning, test design, test execution, and test result interpretation as mutually supportive activities that run in parallel throughout the project. It's a learn-by-doing approach. The more time a test engineer spends with the testing, the more he or she sees opportunities for improvements and adjusts accordingly. Box testing is about defining the degree of visibility that the tester has to the code and then determining the scope of testing that can and should be conducted. There's white box testing, in which the code is visible to the testing instrument. Since the code is visible, it should be observed and its behavior under test needs to be reported. In a black box situation, the internal code is opaque. The testing instrument has no access to the lines of code being executed. The only information available is the response from the component under test. A good example of a black box test is testing the server-side logic of a website or API. Unless accommodations are made otherwise, the test instrument has no visibility as to how the logic of the website or API is implemented. All that is known is the input and the output. Thus, testing is conducted according to these criteria. Software testing levels. There are 4 levels of software testing. Let's take a look at each. Unit testing is a dynamic test that exercises a unit of code, typically a function. The current trend in testing is that developers write the unit tests for their code. They are the ones that know the code best and are responsible for making sure that the code they write meets the defined requirements. Integration testing is the practice of ensuring that all the components that the various developers are writing work together according to requirements and cause no side effects. Typically, integration testing is performed upon the code base in the common repository branch into which the code from all developers is merged. System testing ensures that the code overall meets the business's requirements. System testing has a very broad scope. This includes not only ensuring that the code meets the predefined logical requirements, but also that the code interacts properly with the other systems it's intended to service. During system testing, engineers observe code performance in terms of CPU, memory, and storage behavior. Also, system testing observes network operations as well. Remember, in system testing, computing environment is just as important as the software itself. Finally, operational acceptance testing is conducted just before the code is about to be released to end users. This testing is also known as UAT, User Acceptance Testing. In this phase of testing, non-technical personnel, internal, and many times customers, use the software to make sure that it meets the expectations at hand. Popular software testing techniques. There are many techniques used to test software. Some of the more popular are A/B testing, usability and security testing, continuous testing, functional versus non-functional testing, alpha testing, beta testing, regression testing, and smoke and sanity testing. Let's take a look at each. A/B testing is the technique of releasing a feature to a small audience of users and then increasing the number of users over time. For example, a company will create a clone of the product code, including a new feature, and release it to a set of servers bound to a specific load balancer IP address. The website will be configured to route every 10th request to the servers with the new feature. If the feature proves successful, traffic is increased to every 5th request, and then to every other request. However, if something goes wrong, the routing to the new feature is terminated. A/B testing is intended to let users perform some degree of real-world testing without putting the whole site at risk. Usability and security testing. Usability testing is intended to determine how easy the code is to use. The scope of usability testing is typically for those features that require direct human interaction. Usability testing goes beyond just testing the graphical user interface of a product. In fact, usability testing APIs is becoming a growing concern in testing circles. For example, human factors and usability test engineers want to know how long it takes for an engineer to figure out how to use a given API. Is the documentation clear? Are the error messages informative? Do the API responses make sense? These are all questions that are answered quantifiably when usability testing. Security testing is concerned that the code is safe to use and that it does not cause critical harm to the system when running. This means that it's not taking on permissions beyond the scope that's needed. It means that the code is not behaving like a bad actor. Also, security testing is about making sure that bad actors cannot get to the overall system and do harm. Penetration tests, also known as pen tests, are a type of test that is usually performed when doing security testing. Pen tests make sure that no IP addresses or ports are left open unintentionally to the outside world. It also means that sites and services can withstand denial of service attacks. Continuous testing is the practice of testing at regular, short intervals throughout the software development lifecycle. Typically, tests are conducted automatically in response to an event in the software development lifecycle. For example, when a developer commits code to a release branch or when a merge is conducted into the overall code base. Also, testing is done automatically on new environments as they are provisioned. The overall intention of continuous testing is to test early and test often. Functional versus non-functional testing. Functional testing is intended to make sure that code logic works as expected, that no side effects are incurred. Functional testing is about ensuring that code behaves according to requirements. Non-functional testing occurs at the system level. Non-functional testing is concerned about how the entire system works. For example, non-functional testing is concerned with network latency, disk I/O, and fail safety. Alpha testing is the practice of releasing code that is considered just good enough for the end users to exercise. It's expected to be buggy. The hope is that by releasing code to a lot of users performing a variety of use cases, that issues not picked up in internal testing will be uncovered. Beta testing is the phase after alpha testing when, having fixed issues uncovered by users previously in alpha testing, the code is considered to be a release candidate. If all goes well in beta testing, the code will be given a release version number, deployed, and supported accordingly. In beta testing, the code is expected to have a minimal amount of bugs that need to be remedied. Regression testing is the practice of making sure that code that is about to be released is operational and does not break code in other parts of the system. A regression test is system-wide. Regression testing is important because otherwise it's quite possible to introduce intended fixes into a system that actually create more problems than they solve. Smoke insanity testing is a testing regimen that's intended to check that the most obvious parts of the system work. Typically in smoke testing, a tester, or the automated equivalent, will log into the system, perform a few tasks, and then make sure all is well. Smoke insanity tests are intended to be fast and just good enough to make sure that there's nothing dramatically wrong with the system. Automation testing frameworks. Test-driven development teams rely on automated testing. A testing framework is used to write test cases, and continuous integration software will run these test cases automatically. A well-developed testing framework or an integrated development environment, also known as an IDE, can be used to run the test scripts. Some examples of automation testing frameworks are LoadRunner, Selenium, and TestNG, which is supported by Maven. Jenkins has a number of plugins that support automated testing. Appium supports automated testing for mobile devices, and there's the tried and true automated testing tool for Java, JUnit. Automation testing frameworks. There are a number of types of automation testing frameworks. For example, number one, a linear scripting framework, which is also known as record and playback. You use the framework to create test steps that get executed in sequence. For example, having the test tool fill in data in a form on a web page and then verify the results. A typical linear scripting framework is Selenium. Number two, hybrid test automation framework. That's one where you use a combination of two or more frameworks. Number three, keyword-driven testing. Keyword-driven testing is a software testing methodology that uses keywords or action words to symbolize a functionality to be tested. For example, consider the keywords login and logout. These keywords will be associated with tasks to execute. The keyword-to-task association is usually stored in an Excel spreadsheet or a database. Automated tests will do a lookup on the keyword and then do the associated tasks. Keyword-driven testing frameworks separate the test creation process into two distinct stages, a design and development stage and an execution stage. Number four, data-driven testing frameworks. Data-driven testing frameworks is one in which test scripts run dynamically using predefined data sets from some sort of data store, such as a database or an Excel spreadsheet. For example, a data-driven test is designed to enter and validate name and address information into a form and will use data that's stored in the database automatically. The testing framework is connected directly to the database, and data entry and validation occurs automatically within the test. No human intervention is required. Number five, a modular testing framework is one in which tests are organized into distinct modules. The benefit of a modular testing framework is that the encapsulation it provides makes updating and extending a given module easier, and that the risk of incurring side effects is reduced. You can think of a modular testing framework as one that supports the concept of test suites, where each suite contains one or many tests, as well as common setup and teardown processes that can be applied to all tests in the suite. JUnit is an example of a modular testing framework. Number 6, behavior-driven development. Behavior-driven development, also known as BDD, focuses more on making sure the software does what it's supposed to do as opposed to worrying about how it does it. BDD tools tend to use natural language constructs that are similar to English-like sentences. For example, in BDD, a common way to express an assertion is to write, expect checkbox 1 to be true, or the variable x should equal 4. BDD is particularly effective when business personnel are part of the development team. BDD allows more people, even those without a programming background, to participate in test design. Popular testing tools. SoapUI is an open-source web service testing application for service-oriented architectures and RESTful APIs. Robot Framework is a keyword-driven test automation framework that uses tabular test data syntax. Popular testing tools. RSpec is a domain-specific testing tool to test Ruby code. It's a behavior-driven development framework that's used in the production of applications. Eggplant Functional is a black box GUI testing automation tool which uses intelligent image recognition algorithms to monitor the display being tested. It's used for mobile testing, cross-platform testing, and performance testing. Popular testing tools. Mocha is a JavaScript test framework for Node.js programs. Its features are browser support, asynchronous testing, test coverage reports, and use of any assertion library. Jasmine is also an open-source testing framework for JavaScript. It supports asynchronous testing, the use of spies for implementing test doubles, and testing of front-end code through a front-end extension. Test-driven development approaches and JUnit 5. Overview of test-driven development. Test-driven development is a software development process that depends on the repetition of testing within short development cycles. Requirements are converted into test cases, and then the software is improved to pass new tests. Developers apply the concept to improve and debug legacy code developed in older techniques. Test-driven development, also known as TDD, is based on a simple principle. Their principle is that the test that describes the behavior of the software to be developed is written before creating the code itself. Operationally, this means that if I am to write a function, imagine getWinner, I write the test for that function before actually writing the code for the function. The developer starts with a failing test and then gets it to pass. Test-driven development cycle. 1. Add the test, or you can also say create the test. 2. Check that the new test fails. 3. Write the code that gets the test to pass. 4. Run the test. 5. Refactor the code if necessary. And then 6. Repeat the process again. Test-driven development advantages. There are many advantages to taking a test-driven development approach to the software development lifecycle. The biggest advantages are fast feedback. Developers are always running tests against the code, even before commits are made to source control. Thus, the feedback loop is immediate. Creation of detailed specification. Developers need a detailed understanding of how the code being written is supposed to behave in order to write the test that's the starting point of the development process. Thus, detailed specification is critical. Less rework. When the tests actually reflect the behavior under development, less rework is required downstream in the software development process. Less debugging. Desired behavior has already been established in the tests that need to pass. Thus, developers do most of the initial debugging in the development stage, not later on in downstream processes. Fast identification of errors. The initial tests reveal errors in code as the code is being written. Testing first makes the errors appear at development time, not later on. Creation of solid code. The tests that the code must satisfy exist first. Thus, the code being written is by nature more accurate. However, in order to maintain a high degree of accuracy, developers must write not only test cases that ensure the code works in what is called a happy path execution, that's when things are going the way expected, but also developers need to write unhappy path tests that ensure that the code errors out in a way that is expected and graceful. Clear interface. In order for the test to be accurate, the interfaces that the code exposes must be clear, maintainable, and flexible. Tests written before coding takes place serve as a continuing reference to determine code integrity. Developers that follow TDD tend to run all the tests in the code base upon initial checkout from the source control management system. Running all the tests first informs the developer that the code base is sound and that he or she can add new code in a way that does not create side effects. Failing tests indicate that the code base is out of sync. Being able to determine the health of the code on checkout by running the tests associated with the code first makes it a lot easier to maintain the code overall. Faster time to market. The practice of test first reduces all development time. Having a developer fix code that he or she knows is a faster process than having someone further down the line in the development process address issues. Fast resolution of issues means faster time to market. Less development cost. A rule of thumb is the most cost-effective place to conduct testing is to push testing activity as close to the developer as possible. Test-driven development is all about having developers do more testing and addressing issues raised when testing. Hence, the cost of development is reduced provided the test coverage of the code is comprehensive. Improved quality is by nature built into the TDD process. Increase in programmers' productivity. Having developers ensure the code as it is being written takes a lot less time than sending the code through the software development process untested, only to have it returned to the developer for remedy when the code is found faulty. Fewer bugs. As mentioned earlier, improved quality is, by nature, built into the TDD process, hence fewer bugs. Simplification of code. Developers only write the code that's needed to get the test to pass. Nothing more, nothing less. As a result, the code tends to be simpler yet more elegant. Adaptability. Test-driven development can be applied to any development environment, from COBOL to Java to more modern languages such as Golang. TDD is about the practice, not about a particular programming language. In TDD, the motto is test first, test often, and write only as much code as is needed to get the test to pass. Overview of JUnit. JUnit is a unit testing framework for the Java programming language. Over 10,000 Java projects have used JUnit as an external library. It's the first option that many developers use for testing Java applications. Advantages of JUnit. There are many advantages for using JUnit as the go-to tool in a test-driven development process. Let's take a look at some of the advantages. In JUnit, the server requirement is eliminated for testing web applications. It's a simple framework for writing automated tests. JUnit has a hierarchical structure. Program code can be tested as a single unit or multiple units. JUnit provides a text-based command line and graphical test reporting mechanism. And finally, JUnit supports test assertions and immediate test reporting. Java, a programming language. The building blocks of Java are standard to any object-oriented programming language. Let's take a look at the building blocks. Abstraction. Java allows programmers to create interfaces and abstract classes that serve as templates from which other classes can be derived. Encapsulation. A class is the key building block of Java. Behavior that is of concern only to the class is encapsulated as private code. Code that's to be used by consumers of the class is made public. Encapsulation promotes reuse in that changes can be made to private code without affecting consumers of the class. Polymorphism. Java supports polymorphism. This means that parameters can be added to a function and thus extend new behavior to the function. In other words, a function can behave in many different ways based on the number and type of parameters passed to it. Inheritance. Java supports inheritance. Developers can create new classes that are derived from other classes. A new class will get all the properties and functions of the parent class automatically. Inheritance promotes code reuse significantly. JUnit 5 with Java. JUnit 5 plus Java requires that certain software be available to design and to run tests. The software required is Java SE, Java 8 or higher, Eclipse IDE, and the JUnit library. Assisted practice. Test-driven development approach with JUnit 5. You are given a project to demonstrate the test-driven development approach using JUnit 5 and Java as a programming language. Hi, so let's get started with Lab 4.1, Test-Driven Development with JUnit 5. The objective of this lab is to show you how to create a set of unit tests in the Eclipse Integrated Development Environment and run those unit tests under JUnit 5. Eclipse is already installed in your classroom virtual machine. However, if you want to run the labs on your own computer, you can easily download Eclipse from eclipse.org. Now, the first thing we need to do is to create a working directory for this lab. In the terminal window of your classroom virtual machine, go to the command line and type makedir space lab.4.1. Hit the enter key. This creates the directory. Next, let's navigate into the directory by typing cd space lab.4.1 and strike the enter key. We type the Linux command clear to clear the screen so that we can have an uncluttered view of the work we're going to do. The code we're going to test is already out on the Simplilearn GitHub repository. So all we need to do is to clone that code down into the classroom virtual machine. At the command line of the classroom virtual machine terminal window, we type get space clone space https://github.com/Simplilearn DevOps official /lesson-04-junit_tdd.git. This is the get file for the Simplilearn GitHub repository dedicated to this lab. We strike the enter key and the cloning process begins. Let's confirm that the cloning process worked. At the command line, we type the Linux command ls, and notice there is a directory lesson-04-junit_tdd. This directory was created by the get cloning process. The directory contains the source code we're going to use in Eclipse in this lab. Before we go on, let's enter the Linux command pwd, present working directory. Take note that we are in the /home/ubuntu/lab.4.1 directory. This is the directory we're going to use once we're in Eclipse. we go over to the running instance of Eclipse in our classroom virtual machine. You can see that Eclipse has no projects loaded into it. Now we're going to load in the code we downloaded from GitHub. We click on the File menu in Eclipse, and from the File drop-down we select Open Projects from File System. Eclipse displays the Import Projects dialog. We click the Directory button on the upper right-hand side of the dialog. We are presented with the file system for the classroom virtual machine. We select the folder lab.4.1, and inside of that folder you'll see another folder marked lesson-04-junit TDD. That's the code we downloaded from GitHub. We click on the OK button on the lower right of the File System dialog. Then we're back to the Import Projects dialog. Notice that the import source is now the JUnit TDD folder. We click the Finish button on the lower right of the Import Projects dialog. The project appears in the Eclipse IDE. Notice on the left in the Project Explorer we can see the file system for the project. We click on the down arrow and we see that there is indeed a package com.tddjunit.java. We click the down arrow and we can see all the files in that package. The files are add.java, maths.java, and subtract.java. We double-click on the file maths.java to open it up in the Eclipse text editor. Notice the class maths has two methods, add and subtract. The method add implements the add interface defined in add.java, and the method subtract implements the subtract interface defined in subtract.java. Now we're going to create a JUnit 5 test case that exercises the method add and the method subtract. We right-click on maths.java. From the drop-down we select New, and from that drop-down we select JUnit test case. Eclipse displays the dialog New JUnit test case. Notice that by default, Eclipse wants to store the unit test file into the same folder as the source code. This really isn't good business. What we're going to do instead is to create a separate directory for our tests. We close the JUnit test case dialog. We return to the Project Explorer on the left side of Eclipse, and then we right-click on the root of the project tree, TDD without JUnit. We right-click on New in the drop-down that appears, and then select Source Folder from the next drop-down that appears. Eclipse displays the new source folder. In the folder name text box, we enter test src. Then we click the Finish button on the lower right of the dialog. Take a look in the Eclipse IDE on the left side. Notice the Package Explorer now displays the folder Test Source. Now it's time to create a JUnit test case for Maths Java. We right-click on the file Maths Java and select New from the drop-down, and then from that drop-down select JUnit test case. The new JUnit test case dialog appears. Start editorial comment. Editor, please notice that at timestamp 4:14 that the new JUnit test case dialog appears. Please put a freeze frame here as I need to explain the various fields in the dialog. End editorial comment. Notice there are three text boxes we want to pay attention to. There's the source folder at the top, package, and name. The directory in the source folder text box is pointing to the source code directory for the project. This isn't what we want. We want the source folder to be the directory test source that we just created. Also, notice going down to the name text box that Eclipse has assigned a default name to the test file, and that default name is maths test. That's okay. The important thing to understand here is that we need to change the source folder to the directory test source. To change the directory, we click the Browse button to the right of the source folder text box. The source folder selection dialog appears. We select Test Source from the dialog and then click the OK button. Then, in the Test Case dialog, we click the checkboxes for Setup and Teardown. Clicking these checkboxes will insert setup and teardown methods into the test case. Start editorial comment. Editor, we might have to put a freeze frame in timestamp 4:23 because I need to describe what setup and teardown behaviors are. End editorial comment. Now, what the setup method does is it provides preliminary behavior that gets run before the test happens. Teardown is the behavior that gets run after the test happens. So for example, if you had to do a database setup, you would put the database setup in the setup method, and then if you wanted to disconnect from the database, you would put the disconnection behavior in the teardown method. Begin editorial comment. Editor, we're going to need a freeze frame at timestamp 4:29 so that I can explain why we're skipping adding the JUnit 5 library temporarily. End editorial comment. Next, Eclipse will want us to add the JUnit 5 library. But before we do that, we have to do some other things with the test configuration. We click the Cancel button to skip adding the JUnit 5 library temporarily. We're going to get back to that. We're presented with a dialog that asks us to select the methods we want to test. And we're going to select Maths, Add, and Subtract. We click the Finish button. The dialog asking us to add the JUnit 5 library reappears. So we're going to select Add JUnit 5, and then we're going to click the OK button. Take a look at the Project Explorer pane on the left side of the Eclipse IDE. Notice that the JUnit 5 library is indeed installed now. Also, when we double-click on the file, mathstest.java, you can see that the file appears in the Eclipse code editor. Notice that there's a setup method, a teardown method, and also a test add and a test subtract method. Test add and test subtract are the tests we're going to run. To run the test, we right-click on the file mathstest.java, and from the drop-down select Run As, and then select JUnit Test. The JUnit tests run, but they fail. Take a look at the left side of the Eclipse IDE. Notice the red bar. This indicates that tests have failed. And then if you look in the Failures text box, you'll see that indeed 2 tests have failed. Take a look at the test add and test subtract methods in the Eclipse code editor. Notice that by default they're given a fail state. You can see it says fail, not yet implemented. Our work now is to get the test to pass. Now we're going to write some code. In the file mathstest.java, we create a private member variable. And we type private maths space class under test semicolon. Okay, so our private member variable is class under test. In the setup method, we type class under test equal new maths. What we've done is created an instance of the maths class that is visible throughout the test case. Next, we'll put test behavior in the method testAdd. Let's recap the important steps. Assisted practice, guidelines to demonstrate the usage of JUnit 5 with Java. Number 1, download Java 8 or a newer version and set up the environment variables required. Number 2, download Eclipse from the official Eclipse site. Number 3, create a new Java project in Eclipse. Number 4, create 2 classes, one to add and another to subtract numbers. Number 5, generate the JUnit test files for each class. Add the files in a different source directory for better indentation. Number 6, confirm that Eclipse has added the JUnit 5 library to the build path. Number 7, confirm that the test cases have failed and the error logs are available in the failure trace section in Eclipse. Number 8, rerun the test cases and confirm that the tests have run successfully without any error or warning logs in the failure trace. Behavior-driven development principles, Cucumber, and its applications. Overview of behavior-driven development. Behavior-driven development is an extension of test-driven development. Behavior-driven development, also known as BDD, focuses on where to start in the process, what to test and what not to test, how much to test in one go, what to name the tests, and also how to understand test failures. Behavior-driven development principles. The first principle is to define a test set for the first unit. Second, make the tests fail. Third, implement the unit. And fourth, verify the implementation of the unit that makes the test succeed. In addition to the guiding principles of BDD, a key concept of behavior-driven development is that software development needs to be managed from both business and technical perspectives. Thus, key to BDD is the domain-specific language, also known as the DSL. The DSL describes those entities and processes that are specific to the domain for which the software is being developed. For example, software being developed for the medical industry will have a DSL that contains the terms and, by association, the software abstractions that describe the medical domain. If the software is being developed for the financial industry, the terms and software entities will describe those entities and processes associated with finance. All development takes place with the DSL as the main means of expression. BDD is intended to take advantage of the DSL to make mappings of business requirements to test assertions a direct association. Thus, many BDD tools provide test expressions that appear as assertions made in natural language. For example, the assertion, expect variable s to be a string. The focus of BDD is to make it so that all members of the development team, business and technical personnel alike, can serve as active, empowered contributors. Overview of Cucumber. Cucumber is a software tool for testing other software by running automated acceptance tests written using a behavior-driven development approach. The tool allows the execution of feature documentation written in business-facing text. Cucumber uses the Gherkin language to define test cases. It's designed to be non-technical and human-readable. Cucumber collectively describes use cases related to the software system. Gherkin, a language for Cucumber. Gherkin is a set of grammar rules that structures the plain text for Cucumber to understand. It serves multiple purposes. Gherkin provides unambiguous executable specification, automated testing, and documentation about the system's actual behavior. Gherkin keywords. Each line of the script must start with a Gherkin keyword followed by any relevant text. The primary keywords are feature, scenario, given, when, then, and, but, that means steps, background, scenario outline, and examples. The secondary keywords are defined using the following symbols along with text. Quotation marks surrounding text for docstring, the pipe symbol for data tables, the @ sign for tags, and the hash or pound sign which indicates comments. Tools for Cucumber. Cucumber is supported by a number of code editors, IDEs, and development frameworks. For example, for supported code editors, there's Atom, TextMate, which is a macOS product, and Visual Studio Code, which is available in Windows, macOS, and Linux. Supported IDEs are IntelliJ and Eclipse, and supported build tools are Apache Maven, Gradle, and Rake. Cucumber with Java. In order to run Cucumber and Java, there are certain software requirements that need to be satisfied. These are Java SE up to Java 8. Be careful, Java 9 and higher versions are not supported yet. Maven, version 3.3.1 or higher, the IntelliJ IDE with the Cucumber for Java plugin installed, and Cucumber Eclipse, which is an alternative for IntelliJ. Cucumber with JavaScript. In order to use Cucumber with JavaScript, there's certain software that's required. The software is Node.js, which is a JavaScript runtime engine, a text editor such as Atom, or Visual Studio Code, or TextMate, which is only available for Mac users. Cucumber with Ruby. In order to run Cucumber with Ruby, you're going to need certain software. The required software is Ruby, Bundler, and a text editor. Cucumber with Kotlin. In order to run Cucumber with Kotlin, you're going to need to make sure that required software is installed. The required software is Java SE version 8. Again, be careful, Java 9 and higher versions are not yet supported for Cucumber. Maven, version 3.3.1 or higher. The IntelliJ IDE with the Cucumber for Java plugin installed. Also, you need to make sure that the IntelliJ IDE has the Kotlin plugin installed. And also, you can use Cucumber Eclipse with Kotlin Eclipse, which is an alternative to IntelliJ. Assisted practice. Behavior-driven development approach with Cucumber. Problem statement. You are given a project to demonstrate the behavior-driven development approach using Cucumber and JavaScript as a language. Welcome to Lab 4.2, Installing Cucumber. In this lesson, we're going to install Node.js, NPM, the Node Package Manager, Visual Studio Code. Then we're going to take a brief introductory overview of Cucumber. The first step is to install Node.js. One way to install Node.js is to go to the website at nodejs.org and download it directly using the download page. Another way to install Node.js is at the command line in a terminal window. We go to a terminal window in your classroom virtual machine. Then, at the command line, we type sudo space apt-get space update. This will do a package update before we install Node.js. Once the update completes, we use the Linux command clear at the command line to clear the screen. Now we'll install Node.js using apt-get. At the command line, we type sudo space apt-get apt-get space install space node.js, and then we hit the enter key. The installation process will start. Then we strike the Y key on the keyboard to continue the installation. To confirm that Node is installed, we type at the command line no space -v. That's strange. At the command line, we're getting a message saying the program node is currently not installed. You can install it by typing, and there's the command. So let's type that command. We'll type at the command line sudo space apt space install space node.js dash legacy. Okay, that works. So let's check the version of Node. At the command line, we type node space dash v. And the version v4.2.6 is displayed. Now, be advised, when you install Node, you'll probably get a higher version number. And that's okay because we want to stay up to date with the current version. But in this case, we're going to go with the version of this installation. Now let's check to see if the Node Package Manager npm is installed. At the command line, we type npm space -v. Notice the output. The program npm is currently not installed. You can install it by typing, and there's the command. So that's what we'll do. At the command line, we type sudo space apt space install space npm. The installation process starts. Then we strike the Y key on the keyboard to continue with the installation. Let's check the version of npm. At the command line, we type npm space -v. And notice we get version 3.5.2. Now, again, when you install npm, you're probably going to get a higher version number, because by default, apt-get or apt-install will always find the latest version of a piece of software to install. We type the Linux command clear to clear the screen. Now we need to go to the website for Visual Studio Code, or what's also called VS Code. So in the browser, we type code.visualstudio.com/download. We click on the button .deb to download the Debian Ubuntu package of Visual Studio Code. Remember, your classroom virtual machine is running the Ubuntu operating system. The reason we're downloading Visual Studio Code is that we need the VS Code integrated development environment in order to run Cucumber. We type ls to find the location of the downloads directory. Then we type cd downloads. We type ls to see if the code download has completed yet. Well, it hasn't. Let's wait a moment. Again, we type ls to see if the VS Code is downloaded. Notice on the left-hand side of the screen, there is a file, code_1-30.2-15 and a whole lot of numbers, .deb. This is the VS Code download. Now remember, when you do this process, you might get a higher version number because the download is going to get the latest version. Now we need to extract the VS Code application files from the .deb file. At the command line, we type sudo space dpkg space -i space and the file name of the VS Code.deb file. Then we hit enter. The unpacking process begins. Once the download is complete, we go to the Applications tab in our Classroom virtual machine on the upper left of our screen. We click the Applications tab and a drop-down appears. We go to the Development menu item in the drop-down. We click the item Development in the drop-down list. You'll notice that a sub-item Visual Studio Code appears. We click the Visual Studio Code menu item. If indeed you don't see the Visual Studio Code menu item in the drop-down list, you might have to go back and try to reinstall Visual Studio again. Anyway, if indeed the program is installed successfully, when you click the menu item Visual Studio Code, the application will start up. Great, so Visual Studio is successfully running. Now we need to go back to the terminal window in our classroom virtual machine and make a directory for our Cucumber work. At the command line, we type mkdir space lab4.2 and then we hit the enter key. Now we navigate to the folder we just created. So we type cd space lab4.2 and hit the enter key. Next, we need to create a working directory for our Cucumber work. So at the command line, we type mkdir space hello Cucumber, HELLOCUCUMBR. Then we strike the enter key. Now we navigate to the working directory by typing cd space hello Cucumber. We go back to the Visual Studio Code application. We go to the File menu and click on the menu item Open Folder. The Open Folder dialog appears. In the Open Folder dialog, we click on Lab 4.2 and then the folder Hello Cucumber. We click the OK button in the lower right-hand corner of the Open Folder dialog. The IDE displays the Hello Cucumber directory. We click the Maximize button in the upper right side of the Visual Studio Code window to get a better view. We're going to open the terminal window in Visual Studio Code. In the Visual Studio menu bar, we click the View tab and you'll see a drop-down appear. We scroll down and click the menu item Terminal. The Terminal pane appears in the Visual Studio Code IDE in the lower part of the main window. We're going to create a Node.js project using the terminal window in Visual Studio Code. In the lower pane, we type npm space init -yes. This creates a Node.js project with a default package.json file. Now we need to make an entry in the package.json file for Cucumber and also install the Cucumber Node.js modules. To do this, at the command line in the Visual Studio Code window, we type npm space install space Cucumber space --save -dev and we strike the enter key. --save -dev tells the npm package installer to make an entry for Cucumber in the development node of package.json. Also, npm will install the node package for Cucumber. Now, what's interesting is once Cucumber is in package.json, the only thing another developer needs to do to install the project is to type npm install at the command line. Then the npm package manager is smart enough to inspect package.json and install all the node modules listed. You can see npm starting to install the node modules for Cucumber. Upon completion of the installation of the node modules for Cucumber, you'll see a listing of the modules dependencies in a tree in the terminal window of VS Code. Cucumber requires that we create a folder named Features. We're going to use the terminal window in Visual Studio Code to create that directory. In the terminal window of Visual Studio Code, we type the command line instructions mkdir space features. We navigate to the features folder by typing cd space features and then striking the Enter key. Next, we need to create another folder named Steps. In the terminal window of Visual Studio Code, we type mkdir space steps and strike the Enter key on our keyboard. When you look at the vertical Explorer pane on the left-hand side of the Visual Studio Code window, you'll notice that there's a folder named Features and a subfolder named Steps. Now we need to create a file, cucumber.js, to store default configuration settings. We navigate to the root of the project folder, so we type cd space lab 4.2 and we strike the Enter key. Then, in the Visual Studio Code terminal, we type at the command line cd hello cucumber. We're in the root directory of the Hello Cucumber project. Now, we need to create the file cucumber.js. At the command line, in the terminal window of Visual Studio Code, we type touch space cucumber.js. This creates an empty file named cucumber.js. Now we need to export the default settings. In the vertical Explorer panel on the left side of the Visual Studio Code window, we select the file cucumber.js. This will open cucumber.js in the Visual Studio Code text editor. We type the Node.js module export statement, module.exports, space and equal sign, open and close curly brackets. Within the curly brackets, we type default colon and a pair of tick quotes. Tick quotes on a US keyboard can be found to the left of the numeral 1 key. Within the tick quotes, we type -- format - options space single quote left curly bracket double quote snippet capital I lowercase nterface double quotes colon space double quotes synchronous double quotes right curly bracket single quote tick right curly bracket. Now I know that's a lot, so pay close attention to the screen and make sure you enter exactly what you see. Now save the file. We're going to create a file named stepdef.js and we're going to put it in the steps directory. So in Visual Studio Code, on the left side Explorer pane, we select the steps folder with our mouse, right click and select New File. We name the file stepdef.js. Now, click on the file step.jf to bring it up in the Visual Studio Code text editor. Once you see the file, click in the file and enter const space assert equals space require a paren pair single quote assert single quote semicolon. This tells Node that we want to create an instance of the assert object which ships with the assert library, which ships with Node, in the file stepdef.js. Next, we want to tell Node to use the given, when, and then objects from within Cucumber. In the editor, we type const left bracket capital given comma capital when comma then right curly bracket equals require paren single quote cucumber single quote, and using the brackets to extract variable names is special to ES6. If you're using ES5, this probably won't work. But under ES6, you can pull out a number of objects from one given library using the multiple declaration within the curly bracket technique. Okay, don't forget to save the file. Next, we need to go and tell Node how to run a Cucumber test. So we go back to package.json, and then in the package.json file, which you'll see in the Visual Studio Code Editor, you'll see a scripts node, and beneath that, a test node. We delete the default entry that npm init made in the test node of the package.json file. You can see it says echo/error, no test specified, nn exit. We're going to delete that, so we do. And in its place, we type cucumber-js. This is telling Node to run the command cucumber.js when it comes time to run the test from the command line. So at the terminal window in Visual Studio Code, on the lower part of the pane, we type npm space test. You can see that Cucumber responds with 0 scenarios and 0 steps. And this is okay because we haven't written any tests in Cucumber yet. We're going to write tests in the next lesson. Hi, in this lab, we're going to create a Cucumber test by first writing a feature and scenario with steps in a .feature file using the Gherkin language. Gherkin is a declarative language similar to YAML. We use Gherkin to describe a feature and then a scenario and then the given, when, and then steps that need to be executed within the Cucumber test. Now remember, we're going to write the feature, the scenario, and the test steps in Gherkin. But what we're not going to write is the JavaScript that implements the steps defined in the feature file. Thus, the scenario and the steps are undefined and the test will fail. So, to make a long story short, in Cucumber, we're going to write an undefined test. We're going to write our Cucumber scenario in the Visual Studio Code IDE. We open the Visual Studio Code IDE by going to the Applications tab in our Classroom Virtual Machine. We click the Applications tab and a menu drops down. From that menu, we select the development item and then the Visual Studio Code context item appears. We click Visual Studio Code. This will open up the VS Code IDE. Visual Studio Code opens. We go to the File menu and select the Open Folder item. The Open Folder dialog appears. We navigate to the folder Lab 4.2, which is a project we made in the last video. Then, once in the folder Lab 4.2, we select the folder Hello Cucumber. We click the OK button to open Hello Cucumber in the Visual Studio Code IDE. The Open Cucumber project opens in Visual Studio Code. When you take a look at the Project Explorer on the left side of the Visual Studio Code IDE, you'll notice that the Cucumber node module is installed. When we select the file index.js, you can see that it appears in the VS Code text editor. In this case, index.js is the entry point for the Cucumber node module's CLI library. Cucumber ships with a number of options, CLI, which is the command line interface, and also other libraries that you can use directly as part of the testing process. The important thing to understand about index.js, again, is that it is the entry point for a module, and this is how we know we have Cucumber installed. Now let's see if we can get a test running. In the terminal window of the VS Code IDE, which is in the lower part of the screen, we type npm space test. And notice that Cucumber tries to run, but it reports that there are 0 scenarios and 0 steps. This makes sense because we haven't written any scenario for the test yet, nor have we written the implementation code behind it. So let's start at the beginning and write the scenario. We collapse the Node Modules folder and navigate up to the Features folder in the Hello Cucumber project. Now, as you might remember from earlier, Cucumber requires that we have a Features folder and that in the Features folder there is a .feature file and also a folder step_definitions. The feature file we're going to create is named is_it_capital Friday_yet.feature. So, in the Explorer window of the VS Code IDE on the left-hand side, we click on the Features folder, and then we click on the New File icon, which is to the right of the Hello Cucumber listing in the Project Explorer of Visual Studio Code. A text box appears in the Project Explorer for the file, and we type is_it_F Friday_yet.feature. This feature file will describe the scenario that Cucumber is going to support. Now it's time to write the feature. In the first line of the text editor, we type feature: is it Friday yet with a question mark. This is the feature definition. In the second line, we put an indent and then we write a description. The description is everybody wants to know when it's Friday. Now, be advised, this description is arbitrary. We can put anything in there we want. Its purpose is to provide descriptive text so that people who are running the test know what it's about. We skip a line, and at line 4, we enter the scenario. So we indent, and then we type the word scenario followed by a colon, space, and then Sunday isn't Friday. This is our scenario. We want to test in a behavior-driven manner that we can prove that Sunday isn't Friday. Next, we need to enter 3 steps: given, when, and then. And these are fundamental to Cucumber. In other words, we're going to say, given a certain condition, when this is enforced, then this needs to happen. So let's write these steps. First, we write the given step. So we indent, and we're at the same indent level as scenario. We type given space today is Sunday. We enter another line, number 6, and at the same indent level as given, we type when space I ask whether it's Friday yet. That's the when step. Then we enter another line, and then at line 7, at the same indent level as when, we type then space I should be told quotation nope quotation. So let's review. We've set up our feature, then we've defined the scenario, we've written the given step, the when step, and the then step. Now let's run the test. At the terminal window in the VS Code IDE, we type npm space test. This command runs the test instruction we defined in the last video in the package.json file. The test runs. Notice that the response is that one scenario is undefined and that 3 steps are undefined. And this makes sense because we've written the scenario in the feature file, but we haven't implemented the actual test behavior in JavaScript. And that's to come in the next video. Okay, so let's do the lab that's concerned with a scenario that's going to fail and then pass in Cucumber. The objective of this lab is to write a Cucumber test that supports a scenario defined in a feature file. Begin editor note. Editor, we need a freeze frame at timestamp 05. End editor note. The Cucumber test we're going to implement is based on the file isitfridayyet.feature as shown on your screen. The way that Cucumber works is that it will use the feature file to define certain aspects of the behavior test we're going to implement. In the feature file, there's a scenario described, Sunday isn't Friday, and it's given a given clause, today is Sunday, and there's a when clause, I ask whether it's Friday. Finally, there's a then clause, I should be told nope. So let's take a look at how to turn this feature into a Cucumber test. In the Visual Studio Code IDE, we go over to the left to the Explorer pane and we click on the file stepdefs.js. The file appears in the Visual Studio Code Editor in the main page. Notice, please, that the file declares a constant assert equals require assert, and the assert library is built into Node.js. Also, the file declares three variables, given, when, then, and those come from the Cucumber module which we installed previously. In the code editor, we write a function, isItFriday. We add the parameter today to the function. We add the comment, we'll leave the implementation blank for now. Now, the given object takes a constructor, so we'll add one. In the Visual Studio Code Editor, we add the constructor given paren, single quote, today is Sunday, single quote, comma, function paren set, curly brackets. In the function body, we add the statement, this.today equals, single quote, Sunday, single quote. Sunday is a string that we're assigning to the member variable this.today. When is also an object that takes a constructor. The constructor takes two parameters, the condition string and a function. So we enter, single quote, I ask whether it's Friday yet, single quote, comma, function, parens, curly brackets. In the function body, we add the statement, this dot actual answer equals is it Friday, where is it Friday is the function we've defined previously. We pass the parameter this.today into the function isItFriday. Next, we implement the then object, which is also a constructor. We type, single quote, I should be told, curly bracket string, curly bracket single quote, where string is a format parameter. Then we add the function parameter. We type function, paren, expected answer, paren, curly brackets. In the body of the function, we type the statement assert.equal, paren, this.actual answer, comma, expected answer, paren, semicolon. This statement asserts that the condition we're testing for is actually enforced, that the actual answer equals the expected answer. Now, let's execute the test. In the Visual Studio Code IDE, the terminal is in the lower pane. At the command line in the terminal, we type npm space test, where test is defined in the package.json file. The Cucumber test runs, and you can see it fails. Let's review the test in the terminal. Given today is Sunday, when I ask whether it's Friday yet, I should be told nope, but I'm not told nope. Nothing happens. Thus, the test fails. We clear the console in Visual Studio Code by typing the Linux command clear at the command line. We edit the function isItFridayYet. We go to the function and we remove the comment we placed there previously. Then we type return space single quote nope single quote semicolon. Thus, whenever we call the function isItFriday, it will return the string nope. Now we run the test again in the terminal of Visual Studio Code. This time the test passes. Let's recap the important steps. Assistant practice. Guidelines to demonstrate the usage of Cucumber. Number 1. Install Node.js and NPM from the Node.js official website. Number 2. Open Visual Studio Code and check the version of Node and NPM. Number 3. Create an empty Cucumber project folder. Number 4. Add Cucumber as a development dependency to Visual Studio Code. Number 5. Create a folder feature and in it create another subfolder, steps. Number 6. Add the code to the respective files. 7. Verify Cucumber installation. And 8. Confirm that all the scenarios and steps have passed. Key takeaways. You are now able to describe the benefits of traditional and agile approaches to software testing. You can describe the levels and approaches of software testing. You can demonstrate a test-driven development framework with JUnit. And finally, you can demonstrate a behavior-driven development framework with Cucumber.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.